Hi, I'm Bradley Bartz. I'm a group program manager with Microsoft focusing on Azure Stack. And I brought with me a bunch of members from the team. I hope you're ready for some fun today. This is intended to be a good round of demos. We're going to get into some code. So out of curiosity, how many people in the audience are developers today in this room? Good, you're in the right track. Okay. How many people are IT and ops? That's also good. We'll cover some of that too. Okay, this is really about showing kind of the promise of what Azure Stack is, especially in some of the hybrid blueprints the team has been working with our customers to develop. So we're going to get started and go through this. So we have a couple of slides up front before we get started, just to kind of do some context setting, and then we'll get into the demos. Azure Stack is part of our hybrid strategy with Azure. So it is that portion of Azure that can run outside of the Azure data centers, running in self-host environments, but it still provides the productive, intelligent, and trusted environments for running in those parts of it. So you all know as developers, hybrid can mean a lot of different things. There's lots of meanings of hybrid. So if we have a hybrid identity strategy, you don't need Azure Stack for that. For example, AAD can federate identities from ADFS on-premise, and you can do directory sync between AD and ADFS and do single sign-on, and you can build a hybrid identity platform. The same is true for security. You can do hybrid security with Operations Management Suite, manage security in our security center between what's running in Azure and on-premise. We have a hybrid security strategy and management strategy. We also have a hybrid data strategy with StretchDB and SQL Server 2016 and doing hybrid data between on-premise and Azure. Lots of investments going for hybrid data. But what's missing in that equation is what about hybrid apps? What about applications that need to run across cloud boundaries, that need to have a borrow capacity from Azure or straddle what's running inside premise, or applications that require data sovereignty constraints or have data gravity where the data needs to stay inside the firewall on premise? What do those scenarios look like? That's where Azure Stack comes in. It's addressing this common app pattern for building hybrid applications that need to exist in multiple cloud environments. So that's what we're going to go through. That's where Azure Stack complements our hybrid strategy in Azure. How do we go about this? You've seen this slide. I won't belabor it a whole lot. Hopefully you've seen it. But the best way, okay, quick pop quiz. Forget Azure, ignore Azure Stack for a moment. How many Azure environments, how many Azure clouds exist today? Well, public, there's the public cloud, right? Is there another one? Government cloud, there's 2. Germany, there's 3. China, there's 4. You can actually, if you go into PowerShell and you go get Azure RM environments, you'll get 4. Those are 4 Azure environments that exist today. Each one of those are distinct Azure environments. They have their own Azure Resource Manager. They have their own portal. They have their own AAD instance. They have their own marketplace. They are distinct Azure clouds. Okay? And they are consistent with the other Azure clouds. Okay? And that's what this diagram, so Azure Stack extends that model. We bring that Azure environment outside of one of our operated data centers into a data center that you can operate, or inside your a company's data center, or inside a service provider's data center. But it is the equivalent of one of our other sovereign cloud properties, but a mini version that you self-host. And that's the way to think about it, and it is that consistent Azure platform. Why does this matter? One of the questions we get, why are we investing in this? Okay, here's what I want to know. How many people in this audience are ISVs building Azure solutions? A couple of folks, okay. Others are building basically your own corporate solutions or business solutions, all right. Here's one of the reasons why it's so important to us. Right now, Azure is in 42 regions across the globe. And you just heard Jason Zander talk about it, and Scott. You know, we have the largest footprint on the planet for a cloud offering, okay? Even that's not enough. We're hearing from companies that they need their applications running in areas where Azure isn't. We're hearing from our ISVs that they need to be able to expand the reach of their solutions they're building for Azure. So then we introduce Azure Stack, and we introduce it for service providers that can start to offer Azure services in geographies where Azure is not. What that just did is broaden the reach to our ISV community. They're building solutions for Azure. They can now take those solutions and sell it to a much broader range of the market than they could have addressed before. So we're increasing the addressable market for our ISV community. enter our self-hosted enterprise environments, we get even more footprint of the planet covered. This is why it matters to us. It's about growing the addressable surface area for our app patterns. For the folks in this room, this is why it matters. You're writing the cloud apps. This is about giving you guys and gals the broadest reach possible for the applications that you're developing so they can run in the widest variety of data centers across the globe. That's why this matters for both our own applications, but our customer applications as well. All right. I promise we're going to get through these slides really quick. Okay. Since you're developers, I'm not going to get away with calling this an architecture. This is more likely referred to as a marketecture. A simple abstraction of some layering in Azure, but it's useful for a conversation standpoint. We start at the top. There's a way I get access to the cloud. So when you're writing your PowerShell, you're dispatching your JSON templates to provision resources in the cloud, you're going through a set of APIs, a set of REST interfaces that actually are exposed to the Azure Resource Manager. The Azure Resource Manager is the control plane to our cloud offering. Everything you provision in the cloud is done through that. We have a portal on top of that. We have SDKs on top of that. We have tooling integration on top of that. Okay, that's there. Below there, we have our PaaS and IaaS services. Below that, we have our cloud fabric. What is Azure Stack? Same basic architecture. It has this. We don't have a separate SDK, by the way. It's the same Azure SDK. It works for Stack and Azure, just like it does for our German cloud, our China cloud, our Gov cloud. Same portal, same Visual Studio or other tooling integrations. Same resource manager, control plane is the same. The PaaS and IaaS services that are in the box support the same Azure contracts, can be used. We start to get a little bit of difference down in the infrastructure. The infrastructure is really designed as an integrated system for running on small footprints, so that you don't have to have a shipping container for Azure delivered into your data center. You can basically deploy it on a set of racks running in your data center. So you can get a much smaller footprint for Azure. But that's what it is. At the end of the day, that provides an app compatibility layer, so your apps run the same. In Azure and Azure Stack, you can go to the same contracts, have the same deployment, same automation, same people, processes, and artifacts that you use for this consistency between developers and IT pros. All right. Who's done with these slides? I'm done. Let's call it quits. Right now, I'm going to have David Armour come up and kind of give us a tour of some of the IaaS capabilities in Stack and our IaaS and PaaS platform.
As Bradley mentioned, I'm David Armour. I'm going to cover for you IaaS running on top of Azure Stack. Now, maybe a lot of you run IaaS today inside of Azure, and this will look really familiar to you. Maybe some of you haven't used Azure yet. And maybe even some of you even think that IaaS equals virtualization. And I'm here to show you today that IaaS is not just virtualization. IaaS is something a little bit different. And I show you that in 3 ways. First, I'm going to show you that it's not virtualization, because in IaaS, you can describe what you want in code. So I'm going to show you that in just a second. Second of all, I'm going to show you that with IaaS, you can manage within your virtual machine, which is something that you don't typically get to do inside of virtualization. You usually have to remote desktop into it to do anything, right? And then the third thing I'm going to show you is that you can manage the resources that are connected to your virtual machine, something that you can't typically do in a virtualization environment. So, and then finally, I'm going to show you that there are constructs within IaaS that you don't find in virtualization, which allows you to stamp out replicate copies of something over and over again so that you can scale on demand. So let me go and show you these things. So first thing I'm going to do, if you're familiar with Azure, is I'm going to simply create a virtual machine. Oh, before I do that, I just want to point out something here. This is Microsoft Azure Stack, not Azure. And look where it's running. It's running in Orlando. And oh my goodness, look at this. I am logged in with my corporate identity. Same corporate identity that I log onto the Azure portal, I can log on to my personal Azure Stack that we have set up and running. Okay, so let me go ahead and deploy a virtual machine from the gallery. Look at, in Azure Stack, you can populate the gallery with the same things that you would find in Azure. So I'm going to go ahead and deploy a SUSE VM here. Give it just a second because we went to sleep for a little while here. All of those templates that you saw for me to deploy inside of the marketplace can be syndicated with Azure. So your administrator of Azure Stack can simply go up to Azure and pick the images that they want to pull down into Azure Stack. So I'm going to go ahead and deploy this VM. I'm going to try to do it as quickly as I can here. So let's just do Ignite. Let's choose a user. I'm going to do the password option because it's easier. Okay, and let me pick my resource group here. All right. Next thing I want to show you is that Azure Stack has lots of sizes to choose from for your VM, just like Azure. Unlike virtualization, I don't get to custom pick all of the things that I want for my VM. I pick from a catalog, and because it's a catalog, I get just a consistent set of things. So I'm going to go ahead here. You can see I have DS sizes, I have some D sizes, I have some A sizes even. I think I'll go ahead and pick this DS3v2. There's a whole bunch of settings that I get to configure. Things that I used to have to call my IT guy for, like what network it's going to get put on, or getting a public IP address for the thing. I'll get into extensions a little bit later. I can set up monitoring. I can say, hey, I want to get this monitoring inside the guest set up, so I can enable that. If you've used Azure, you're very familiar with this wizard. I did click OK. Okay. All right. So before I deploy, and I'm actually not going to deploy, I'm going to go here and look at the template for this. So let me just, in case you can't see it, I'll zoom in here. At the very bottom, it says download template. Let me go ahead and bring that up. All right. So I see I can look at the code that's going to be used to deploy this VM. And this is important because I only have to go through the wizard once to get this spit out. And from that, I have the learning on how I can put this into whatever automation system that I have. It shows me how to do it in JSON. I can go ahead and look at it in our CLI. I can go ahead and look at how you do it in PowerShell, .NET, or Ruby. So this is infrastructure as code. It allows you to define how you're going to roll out your infrastructure and put it into your source code management system. And then you can repeat it over and over again. Pretty cool. All right, I'm going to jump out of here. And I'm going to go to my resource group and session demo. Okay, I'll just quickly show you again why we're not just talking about virtualization, because you can see I have a whole bunch of resource types that are associated with my VMs. So let me just quickly zoom in here. If you used Azure, you're familiar with all of these things. I have things like load balancers. I have even my network interfaces are objects that I can manipulate. I have public IP addresses, storage accounts, and of course, virtual machines. One of those virtual machines I'm going to log into or get into right now. And just like you would see in Azure, I see all the things about my virtual machine. If you come to my session later in the week, I will show you all the really cool things that you can do with this virtual machine. I don't have enough time to do that today, so I'm just going to show you a highlight of that. And this is what we call extensions. A virtual machine extension is a way for me to manage inside my virtual machine without ever having to log into it. In fact, if you look here, I've already installed a couple of extensions in here, including anti-malware and diagnostics. I didn't have to log into this virtual machine and install anti-malware. I simply pushed the extension for anti-malware into the virtual machine. Now I'm going to do the same thing with a custom script. Now I'm not going to tell you what the custom script does right away. because it takes a little while for it to run. So I'm going to go ahead and kick this thing off. I simply pick the file that has the thing that I want to run. Session demo. I'll zoom in to show you what I've done, I think. So here's my session demo. All right, kick that off. Okay, that's going to take a couple minutes to run. So while it's running, I'm going to show you a couple of other things. First of all, what did I just run? Well, this is a Windows machine, and this Windows machine I've set up Docker on it. And what I'm doing is I simply provided this script here, which is going to install WAMP onto this VM. So in a few minutes, I'm going to be able to show you Apache running on top of this Windows server inside a container. So, so that's running. Do you guys see what port that's on? 8080, right? Well, I can't just get to 8080 unless I open up a firewall for that. Well, guess what? That's self-service in IaaS. So we have a thing in Azure and Azure Stack called a network security group. And I'm going to go ahead and configure that network security group to open that port so I can get into that. So I have a network security group here called, where is it? Oh, here we go. For my Windows server. And you can see I have some inbound security rules, and I need to add one. I have one currently for RDP that was automatically created when I deployed this VM. But I'm going to go ahead and add one for 8080. In fact, I'll even call it 8080 as the name. And I'll simply make the port range just be 8080. Pretty simple, huh? I didn't have to call my networking guy to open up that firewall. It's all self-service. I can take care of myself. So next thing I'm going to do while that's configuring, oh, it's already done. Sweet. I'm going to go back to my VM. Where is it? There. No, that's the IP address. There we go. Okay, and you can see that my IP address is right here. I can go ahead and copy that so I can get into this VM. So let me copy that. Open up another. Put port 8080 on there, and hopefully it's already done. So you go. So you got Apache running in a container on Windows. If you come to my session, I'll show you how to do that on Linux. And I'll even show you how to do it on Docker Swarm if you want to do that. But for now, I'm going to show you the next really cool thing that you get with IaaS. When you run at cloud scale, if you had to manage each virtual machine that you need to create as you get more and more and more and more users, that'd be a real drag. So one of the things that Azure has is a thing called a virtual machine scale set. And what that is a set of VMs that are all identical to each other. And as your demands grow for your app, you can simply scale out more and more of those virtual machines using the same recipe over and over and over again. So I have one of those deployed right here. Now, how easy is it to scale this thing out? Oh, too easy. I can simply go here to the scaling tab. As it's loading, I'll show you what it looks like. See, scaling. And I can simply change the number of instances, just like that. I'll go in again. See that? And then I can click Save. And what will happen is Azure, actually Azure running inside of Azure Stack, will create 2 more instances identical to the previous 2 with the same firewall rules, with the same internal configuration. Any code that was inside those VMs is going to be also provisioned inside of the 2 new VMs so that they'll all end up identical. So there you go. It's not virtualization. It's actually a cloud VM. And IaaS on Azure is awesome, and it's even more awesome because you can run it in your own data center inside of Azure Stack. If you want to learn more about IaaS on Azure Stack, please come to my session on Wednesday night at 4 o'clock.
All right, great. Thank you, David. So One of the things that's cool about the IaaS solution in Azure, I don't know how many of you are aware of this, but the IaaS solution in Azure has actually evolved in the last couple of years. And today, when you go to the portal, you actually see remnants of that evolution where you have something called Classic Compute and now Compute. Classic Compute is the original IaaS implementation in Azure. And when they were building IaaS in Azure, one of the things they did was they realized that they needed to make some changes. They needed to make IaaS better in order to support modern PaaS platforms. And so they evolved the definition of IaaS to have things like VM scale sets, to have this elasticity, to have the composability, to have infrastructure as code. They really remodeled IaaS as a foundational service in Azure, and it is now the basis of modern PaaS platforms. They sit on top of that IaaS layer. That is the same IaaS layer that is in Azure Stack. So Azure Stack comes with that rudimentary IaaS capabilities that is really the accelerator for modern PaaS platforms. Okay, so next what we want to talk about, so you've seen kind of the basic compute capabilities that are in Azure Stack. The next thing that's part of building applications, and we're going to get into applications, so bear with me. So we're going to work our way up there. The next step we're going to look at is some of the tooling options, because part of the promise of Azure Stack is having a consistent tooling experience. Whether you're building on Windows applications, whether you're building Linux applications, it doesn't matter. How do you have that consistent experience between Azure and Azure Stack? Because that's what allows you to have this virtuous cycle. By the way, let me talk about this. I'm curious, in the audience right now, how many companies or folks, how many people in your company are going to be able to move 100% of your applications into the public cloud? At least there should be one hand. Not one. Okay. How many people or your companies are going to be able to move a subset of your applications to the public cloud? Okay. Most hands. How many of you are going to have a subset that's going to stay inside your corporate firewall, inside your business? All right. Once you're in that situation, you now have a new problem. And that is a problem of this. Once you move to the cloud and you start embracing cloud application patterns and designs and using all the cool stuff that's in the cloud, well, one, I'm learning a new skill set, I'm learning new tools, I'm having a good time, I'm doing this stuff. None of that works on premise, but you still got to maintain those apps. So what, do you have another team that does that? Do you have two dev teams? You have the cloud team and you have the on-premise team. They use one set of tools over here, they use another set of tools over there. So all of a sudden, you've got double the cost. And what happens next when you want an application that's going to run in both? Do I have to port the application? I have to have two different forks, two different implementations? What do I do? So once you're in the world where it looked like the most of the people in this audience are in, where you have a bifurcated catalog, some in the public cloud and some on-premise, you have a problem of how do I reuse my code, my people, my processes, my talent, my artifacts? How do I have that continuity? And that's what Azure Stack brings. And by the way, that's one of the differentiators in our cloud strategy with our other cloud environments, is that we provide that continuity and that consistency so that you can use the same automation, the same development tools, the same artifacts that are part of your application, and the same processes. You're using the same skill sets for building those applications across the public cloud and what's on premise. At the end of the day, that's going to create this environment where you can basically have this quick iteration of building applications that are flowing through a CI/CD pipeline, build going into Azure, some going into Stack with that fluidity. Okay, speaking of which, one of the common patterns, I was just at a customer site here last week in Germany, and they did this. They did this on their own with an Azure Stack POC. By the way, another quick show of hands, how many people have actually got an Azure Stack POC in their environment? All right, so everybody with your hands not in the air, you're behind. Just so you know. Okay? Well, at any rate, this other group in Germany, they actually had an application. They moved from on-premise. They ported it into Azure. They used Visual Studio Team Services to do a build and automation verification, deploying it in Azure. They had a building in Azure and deploying into Stack as well. They had an integrated CI/CD pipeline to deploy in Azure, deploy in Stack for that continuity to basically build and test their application. You can do that kind of stuff, and that's one of the things I'm going to have Shri now come up and show us about some of the tooling and DevOps experience that are possible. All right, Shri, it's all yours.
Thank you, Brad. All right, good afternoon, everyone. So I'm here to we talk about platform capabilities here, right? So I'm here to kind of talk about the tools and the DevOps scenarios that you can enable with Azure Stack in conjunction with Azure. So quick show of hands. We're working you out in this session, I guess. How many of you have deployed ARM templates? That's a bulk of the room. Okay, perfect. How many of you have gone through the process of having to update your ARM templates for higher API versions across different resources? Perfect. How many of you have applications deployed across the different Azure clouds that we have? How many of you are software providers? Okay. So basically, when you have to deal with resource providers in different clouds, you have the public cloud, you have the Azure public cloud, you have the government cloud, Germany, the China cloud, and now you will have Azure Stack instances that your software is potentially going to run on. And each of these have resource providers that provide you certain services. So you have, as David showed you, compute, you had network storage, you have Key Vault, web apps, a whole bunch of resource providers living there. The way Azure deals with versions is we have these things called API versions. So every resource type, every resource in a resource provider is versioned. Now, the good thing is they're all versioned and Azure is backward compatible for as long as I know. But the other thing is we keep evolving, and different clouds, different resource providers within these clouds keep evolving at a random pace. So their API versions will start changing independent of one another. So at that point in time, you as an app developer need to be cognizant of the different API versions your resources are at. Otherwise, when you're writing your applications as templates, they will fail. So when Azure Stack comes into the mix, you now have another set of API versions for each of these resources that you need to be cognizant of. Now, when you build an application that runs only on one cloud, it's okay. You know you can manage it. You know what it's going to run on. You know the target platform. So yeah, it's not a big problem. But when you're building hybrid applications, or when you're building applications that can run on more than one cloud, now your application needs to be cognizant of the API versions available on that cloud. And you also have to be cognizant of whether the capabilities in that cloud will suffice for your application. So what we've done is we're working in Azure Stack in conjunction with Azure, the Azure Stack and the Azure Resource Manager teams. We're working on certain tool sets that will help make your experiences better. Now, one of those is what we call API profiles. So API profile is basically something which is a collection of API versions of a namespace. So profile 1 will have Microsoft.compute with a certain API version, Microsoft.network with a certain API version, and storage with a separate API version. So all you have to do is build your app to a profile, and as long as that profile is supported in those multiple clouds that we talked about, your app will successfully deploy because you can be sure that those capabilities exist in that cloud. So we're condensing a lot of the different 6 or 7 API versions that you guys need to remember, and that's, I'm talking about a small app, into one profile that will be deploying across clouds. Now, how do you apply the profile? So let me kind of show you. So this, what you see here is a template. The bigger section of my screen is a template, is an ARM template that deploys a virtual machine. If you look closely at the template, you will notice that there are different resources. There's a resource type called network security groups, and it's on an API version 2015 something, right? And then there is storage accounts, and it's on an API version 2015 6.15. And when you look at virtual networks, it's on a completely different, it's on a different API version value. So what we have in the right is an ARM template. It's the exact same ARM template, but it's got a profile defined on top. So now this profile is internally mapped, and there's going to be documentation on what profile maps to what API versions. But at the top of this template, you define what the API profile for that template is. And when you look at the individual resources in the profile, so the storage account name, check. Oh, there it is. All right. Just too awesome for the mic. I think it's working. you don't have to individually mention the API version for that template. So you can just mention the profile, and when you deploy that template, Azure Resource Manager will internally map to say, okay, this is the namespace, this is the profile, so I will automatically send a call to that API version. So the amount, the values that you need to know to write your ARM templates or version your ARM templates becomes a grand total of 1. So now that we have that, let's go to the second thing. Before you deploy your ARM template, you're going to have to authenticate. You're going to have to have a token that ARM is going to know, and that is the only way you will be able to get authorized to deploy anything to a subscription. That is the ARM authorization model. For you to simply get a token, you need to know where your login endpoint is, what is your AAD endpoint. You need to know a set of credentials that you need to authenticate with. You need to know what is the ARM's resource identifier. For those of you who are familiar with the identity terminology, it indicates what application that token is for. You need to know where your graph endpoint is, where your portal endpoint is. There's a ton of values, like almost 6 to 7 values that you need to know. Again, if you're building an app for one cloud, these values, you can keep going with these known values. But now that we're building hybrid apps, now that we're building apps that span multiple clouds, these are 7 sets of values across clouds, right? Like you have 7 into the number of clouds you're potentially capable of deploying. Let's say you start deploying your applications to multiple Azure Stack instances, right? Now, that just gets compounded by the number of Azure Stack instances that you have to deploy to. So as an app developer, you have to remember these endpoints. But what we're building next is basically an API that lives inside that particular cloud. You can query the ARM endpoint in that cloud to give you information about that cloud. What this makes you do is, like, you can now start building applications that just talks to the ARM endpoint in that cloud. And that ARM endpoint API will give you information about pretty much anything else. Let me show you what I'm talking about. So let's say I go into a browser, I go into management.azure.com, right? This is my Azure ARM. The API we've built out is an metadata endpoints API. So basically, when you go here, Azure will give you a response, and this is an unauthenticated API. Let me throw it into a tool that will format it for me. Okay, so basically, Azure just gave me a set of endpoints that belong to that particular Azure cloud. Now you can hit this endpoint across any different cloud and get back all the other endpoints that belong to that cloud. Now as an application, I just need to use the login endpoint, take the audiences and go to that endpoint and say, here is my credential, please authenticate to me, right? This is from your app development perspective. We've already made use of this particular API in all of our tools. So if you go into Azure PowerShell today, and you're going to have to add Azure RM environment and provide those 6 or 7 different endpoints depending on the Azure Stack or the Azure cloud that you're going to. Azure clouds are already predefined in there, so you may not have had to go through that experience just yet. But when you start talking to Azure Stack clouds, they're not known constants. They're dependent on the installation of Azure Stack. So today in Azure PowerShell, you can actually go and do add Azure RM environment and provide the ARM endpoint. Let me show that to you. So in add Azure RM environment, all I have to do is give the environment name and just the ARM endpoint. Now, when I add this, and I hope I don't already have an environment set up. If it is, it will throw an error. But let's just run this. Okay, so it basically inferred all of the other endpoints. If you look at it closely, there's almost 6 other endpoints that it was able to just fetch from that ARM endpoint that I give to it. So at any given point in time, regardless of which cloud, which Azure cloud you're deploying to, all you need to know is the ARM endpoint. You can pretty much infer everything else directly from the ARM endpoint. All right? That's the second one. So we talked about, the first thing we talked about was API profiles. That helps you deploy applications across different clouds and consolidate versions. Second was metadata endpoint, which lets you infer all of the different endpoints in that cloud. The third thing we're talking about is service principals. How many of you are familiar with service principals here? Quite a few. Okay, so service principals, for those of you who are not familiar with the concept, is an application identity, if you will. This is basically, for the on-premises experts here, this is like a rough equivalent of machine identities that we have on-premises. This is basically used by applications to authenticate themselves with other applications or with the Azure or with the cloud or with the Azure cloud, basically, right? If you come to my session on Thursday, I'm going to go more into detail about how to create service principals, the different topologies and things like that. But for the purposes of this conversation, I've already created a service principal and I have a key. Most of you have already taken photos of my secrets and key, but it's okay. You won't be able to do much with this. But so now that I've added the Azure environment to this particular PowerShell session, I'm now able to authenticate and I'm able to give that service principal access. From this point on, your applications can deploy to that Azure cloud with just the information that you know about the ARM endpoint. So when you write an app, you know what the ARM endpoint is and you know what your credentials are, and you can just work magic with just these sets of tools that we have available for you. That's the second thing. Now, the third thing, when my machine comes up here, okay, I lost my VPN connection. Give me 1 second, please. The network's been really flaky here. Apologies, guys. Okay, I was about to show you a cool CLI demo, but my VPN wouldn't allow me for that, so I'm going to skip past the CLI bit. So the next thing that we're going to see is how do you write an application that will authenticate itself with all the values that I just told you about, the metadata endpoint, the service principal, as well as API profiles, and can actually authenticate itself with ARM and fetch a secret. So the functionality that we have both in Azure and Azure Stack is called Key Vault. I'm hoping a lot of you use Key Vault in your applications today. The Key Vault is an application, is a service which allows applications to fetch secrets, keys, certificates at runtime, which basically prevents the need for them to store these things directly inside the app. So even if your app gets hacked or if your app is in a bad state, the Key Vault has the secrets. So all you need to do is contact the Key Vault and rotate the secrets in the Key Vault. It kind of helps facilitate a runtime retrieval of keys, right? And this Key Vault service is available in Azure Stack as well as Azure. So while I'm in the PowerShell window, let me just show you what the Key Vault service is. So I basically have gone ahead and I've created a Key Vault instance in my RP. The next thing what I'm going to show you is an application. So I have a C# application that I've written that will authenticate itself with the ARM instance. I'm not telling it which cloud it's deploying to. I'm not telling it what endpoints it's got. All this application knows is where the ARM endpoint is and what its credentials are that it needs to authenticate, right? So I'll show that to you. This is my app.config. It's basically got the client ID, client secrets, which again you've already taken a photo of, and just the ARM endpoint that it needs to call to, right? So let me just run this application. So I'm going to build it and I'm going to run it. So this app is now querying the ARM metadata endpoints and it's getting all the authentication information, the login endpoint. It is getting the ARM's resource identifier. It's actually gone ahead and to the AAD instance, it's already fetched a token. It didn't fetch one token, it fetched two tokens. One token was for the ARM instance and the other one was for the Key Vault instance. The ARM token is used to retrieve the vault information, to know where the URI of the vault is, to know more information about the Key Vault. The Key Vault token is to actually go talk to the Key Vault instance to retrieve the key. So if you notice here, this is the Key Vault token, and I can also add the ARM token. So there's 2 tokens that the tool retrieved. Once this is done, what I'm going to show you is the tool actually going and retrieving subscriptions. Once it's got the subscription, it's going to go ahead and retrieve a key from the key vault. So let's make progress. As you can see, it listed all the subscriptions that I had in that cloud, and it was able to pick a particular subscription, go into the key vault inside that subscription, and is able to retrieve the key that I've stored inside that key vault. Now, this can be a connection string. This can be a certificate that you're using to talk to another application. This can pretty much be any secret. This security solution allows you to fetch these details at runtime and enable your application to actually be independent of the cloud that it's running under. So that's the third thing. There's one last thing I'm going to talk to you guys about, and I promise I'll hand the baton off to Brad. We talked about the service principles aspect. We talked about getting the endpoints from the Federation metadata system. We talked about profiles and how they can help you build applications. And we talked about, we saw PowerShell. We weren't able to get to CLI, but we saw PowerShell as well. Now, all of these functionalities together help you with your CI/CD system. It will help you build and deploy applications with infrastructure as a code, continuous integration, continuous deployment directly from VSTS. So I'm going to show you some of the cool things that the VSTS team has been doing with Azure and Azure Stack. Now, again, one last show of hands. How many people use VSTS in the house? All right, cool. And yeah, including you, Scott. And I'm assuming a lot of you use that to deploy applications to Azure as well as your on-premises infrastructure. VSTS has a really cool integration where it is capable of identifying Azure resources and Azure subscriptions, and it helps deploy your applications directly to Azure without you needing to know the underlying details of authentication or resource group management or anything to that effect. You can do all of that stuff directly from the VSTS instance. Now, we've been working with the VSTS team, and you can now deploy applications to Azure as well as to Azure Stack through VSTS. And this is again in private preview, and this is probably the first set of people to see this set of features. We've just recently started going on a private preview with this. When you go into your VSTS deployment page, when you have a lot of deployment release steps, you can now, in addition to your Azure environments, be able to add your Azure Stack environments as well. This is one Azure step in VSTS, which is create or update resource deployments, which is basically going to deploy a template to an Azure, to an ARM instance. And I'm going to sign in. Usually what happens here is when you go into the Azure subscription dropdown, you will be able to see only your Azure subscriptions in here. But now what you can do is you can hit manage, and once you're inside this page, you add a new Azure Resource Manager endpoint. This is how you deploy things to Azure. This is how you've been traditionally deploying things to Azure. Now, in addition to Azure Cloud, you will also see the ability to deploy to an Azure Stack instance directly integrated as a part of VSTS. All you have to do is to select the Azure Stack instance and give these particular endpoints that you need. Again, they're working on the integration with the metadata endpoint. So once you have the ARM endpoint, they will be able to infer everything else. This is a preview of what we're showing you. And right below, you have a verify connection. Now, if your Azure Stack instance is exposed to the internet, VSTS can reach out to it, make sure that the values that you entered are accurate. It will be able to test the connection. It will authenticate, be able to fetch subscriptions, resource group, resources, and will be able to test the connection. In this particular instance, it will not be able to test my connection because my Azure Stack is in a disconnected fashion. We're working with the VSTS and the TFS team as well to do this on a completely offline scenario. So TFS, when this feature gets enabled in the TFS instance, you will be able to verify connection through disconnected environments as well. Now let's take a look at something that I already have. I have an Orlando stack and I have a Redmond stack. The Orlando is what David was using. So if I just open this up and look at the Orlando stack, hello, yeah, this is the endpoints that I provided a little while ago for the Orlando environment. I can give it the subscription name, I can give it the environment ID, And when I go back to my release steps, here, instead of the Azure cloud that you potentially see, you can deploy to an Azure Stack one node. And when your releases go through, you will be able to deploy your applications to Azure Stack as well as to Azure in the exact same consistent fashion. And with that, I'm going to hand it back to Brad.
All right, thank you, Sri. Okay, so far you've seen, some basic compute capabilities. This whole versioning thing, you may not have been aware of that, but there is versioning. And it kind of matters because when you're calling Azure, you could just be using the latest feature that they just shipped yesterday. Because you just call it, it's available there. So being aware of the versions allows you to have more, to intelligent target what capabilities you want and ensure those capabilities exist in both environments. All right, so now you've seen some of the compute, some of the tooling. A lot of you already have exposure to that. But now, what can I do with that? Where do I go from that? Let's talk about some of the hybrid applications. I'm going to move quick here and get to the meat for some time savings. There's 3 key use cases that our customers have come to us telling us they're wanting to build. One is for edge and disconnected, which are really applications that are primarily based in Azure, but also have code that needs to run out at the edge. By edge, I mean beyond Azure, outside, oil rig. Think oil and gas, think mining, think shipping, think factory floor kind of scenarios. Another category is in our regulated industries, think healthcare, financial sector, government sectors, where they have to meet regulatory constraints. And last but not least is basically applications that are essentially becoming cloud ready, embracing a cloud model, even for things that are going to stay on premise and aren't necessarily going to go to the cloud, to the public cloud, but they want to embrace a cloud model. Okay, 3 key use cases. And there'll be more sessions that go into details on those use cases. These are more examples, but what I want to show you today are some of the engineering patterns to build these use cases. Here's an example of edge and disconnected. Well, basically, we saw an application where it's running in Azure, and that application that's running in Azure is going to get data that needs to come from on-premise. Common pattern that we see where there's some processing that happens on-premise as well as processing that happens in Azure. I'm going to invite Anjay and Matt to come on up, and they're going to give us a demo of an edge scenario that they've been working on to basically demonstrate this. And so I really want you to get a chance to see this code and not have to see a lot of slides. So.
Sorry, guys. All right, so we've seen some of the really good foundational steps in terms of building hybrid applications, right? Applications that span on-prem and the cloud. So we're going to get to go into some of the higher level constructs that you can kind of make with this. So we'll call these kind of applications of the things you've just kind of gone through. So that hybrid CI/CD pipeline, we can also use it for the ARM templates themselves, versioning our infrastructure, kind of like we would version the code. Right now we're going to talk about an edge scenario, a scenario in which there's limited bandwidth between the edge and the cloud. And specifically, we're going to focus on video processing. Sending video feeds directly to the cloud is kind of onerous in terms of bandwidth and can be expensive in certain locations. So this is an application that would be kind of nice if we could just do at least a chunk of it on-prem. It's also something that we'd like to be able to kind of scale quickly. So imagine you have a number of locations around the world in which you want to do this, and you just want to be very quickly kind of deploy that application and the infrastructure, get it out there and get it going. So you can kind of just imagine packaging that up with our hybrid CI/CD pipeline and then dropping it onto an Azure Stack. So the whole thing, it can go from nothing, just an empty Azure Stack, to having the application running. So let's dig in a little bit about what this specific application would look like. So for image processing, video processing, it's pretty common to do a lot of your training in the cloud where you have a lot of compute resources, right? In some cases, it's really nice to use graphics cards. I don't know if you guys have ever used some of the deep learning technologies out there today, but when you train neural networks, it sure is nice to be able to use unlimited compute capability that the cloud offers, right? But when we're in an edge case, it's going to be limited, right? And so we do the inference at the edge, and we do the training in the cloud. And what the hybrid CI/CD pipeline allows us to do is take that model and package it up and then deploy it directly to the cloud. So the pipeline spans both Azure and Azure Stack. So again, everything you just learned with Sri about how to connect your Azure Stack up to that pipeline, it's just another deployment environment, right? So now we've got our Azure Stack deployment environment that will be running our application at the edge. And then I promise this diagram doesn't get too much more complex, but in the Azure Stack Edge, we're going to use some of the capabilities David alluded to. We're going to use Docker to package up that application, and then we're going to bring it back down to Azure Stack after we put it up into the Azure Container Registry, if you guys are familiar with that, and then deploy it on a Docker Swarm cluster inside of Azure Stack. So using our Azure Stack IaaS capabilities, Docker Swarm runs as a VM scale set. You guys saw that earlier where we can scale out VMs. The template we have in here will lay down that infrastructure, and then you have your Docker Swarm cluster, and we can bring the container down on top of that. So that's the application and the infra interacting there. And then cameras. So we'll talk a little bit more about the cameras, but cameras will feed into that kind of containerized setup. And then, at the end of the day, we still want the results maybe in a place where we can get them kind of globally. So we may send up those results periodically when we do have connectivity to the cloud. And the key thing here is we're not actually going to send all that video data. Think about all that video data that's coming in. We're only going to send the frames we're actually interested in. So the Azure Stack compute and storage capability is really only about maintaining enough data and compute capability to handle the recognition of the photos that are actually interesting to us. And then we'll periodically send that up when we have connectivity. And here's the full diagram, and Andre will kind of take us, get us started here.
Let's get this set up. Sorry, we need to enable the VPN again. Let me go ahead and switch this over. All right, so what we have here is our organization's investment in Azure. Most of you, we were watching the hand raises. We don't want you to get too worn out. It's the end of the day. You've already got investments in Azure, or you're exploring investments in Azure, or the people that develop software at your company, they have experience with Azure and the Azure cloud development model. We don't want that to go to waste, which is why we have Azure Stack to bring the cloud on premises. And we don't want to make sure that your prior investment in the cloud goes to waste either. So we've got this resource group here. It's very simple. It's just got a couple of storage accounts. We've got a data science virtual machine. It's something we offer that we use to simulate our models, that training that Matt talked about in Azure. That's our organization has already been doing this training and recognition in Azure, but they want to bring it on premises so that way they don't have to ferry all that video data back and forth. So they've got this data science virtual machine, and then they've got just a few other things to bring it online. And then the most interesting part is this Azure Container Registry here. Let me zoom in case you can't see it. The Azure Container Registry. It's a private registry for our containers alone, so that way we can deploy code through our VSTS pipeline and publish it to any Azure Stack that we own on premises without worrying about that escaping or going public without our knowledge. So let's go ahead and switch over to, and I'll run you through the pipeline to Visual Studio Team Services. So this is VSTS. All of our work is done in Visual Studio. We ran the full VSTS hybrid pipeline. And all we really do is we take once code is checked in, we build an image and we push the image to our private container registry. And then it's published to a staging server that Visual Studio handles automatically. We don't have to worry about making sure there's storage available. We don't have to worry about setting up a build agent. All this is handled for us automatically. When it's time to release it to a brand new Azure Stack or to release an updated model to a current Azure Stack, we have a very simple release pipeline enabled by those new Visual Studio Azure Stack specific tasks that Sri showed us. So we just deploy the Docker Swarm infrastructure and then run a simple Python script to deploy that, to get that image from the cloud and deploy it on premises. And then Matt will take you through exactly what happens on Azure Stack.
Sounds good. You might have to bear with me for 1 second as we kind of get back into the Azure Stack environment. I got it. 1 moment. Alrighty, there we go. Okay.
While he's doing that, I do have one question to ask. How many of your organizations deal with a lot of data that you have to filter through on a daily basis and look at outliers? Anybody? Anybody? Okay then.
All right, cool. We're back in Azure Stack. So let's first take a look at the Azure Stack resource group. Let me flip it back over. So again, here we are in Azure Stack. Now this has a series of resources we kind of discussed. So remember we had that Docker Swarm cluster, right? So that's going to be kind of the basis for where our compute is going to land inside of Azure Stack. We also have functions in here. And what are we doing with the functions? So we have 2 different functions. One was allowing us to send back our data to Azure when we've identified images that are of interest. So that's kind of the way we're syncing to our what we call our Azure forwarding account. So there's an edge, there's a function that will sit there and just kind of wait for the data to be identified and then send the data back up. Then there's another function that emulates a camera. So if you guys are familiar with like IP cameras, you'll get frames that come through, and what this does essentially just slices them and then puts them onto a queue. And the queue allows us, so this is queue storage, the same as in Azure. It just allows us to make this thing scalable, right? So all of a sudden we can deploy a lot of those containers on that Docker Swarm cluster and retrieve more and more images off that queue. So you can increase the throughput through the pipeline. We'll kind of briefly go through and just look at those functions, and if we get a second, we'll try to go through the pipeline here. But here is the functions account. So what we'll do is we'll go ahead and simulate kind of taking an image from an Azure Stack environment. So the camera would be connected to the Azure Stack environment. It would pull in the image, and then that image would be sent to the queue to be learned on. So here, I'll go ahead and go to the camera function, and I'll just go ahead and run that. So all we're doing, again, is just simulating taking a picture, and we've added it to the queue. That's great. So now, within Azure Stack, so we still haven't left Azure Stack yet, we can go ahead and see the scored image. So we just have a pretty simple setup here, positive or negative. Right now we're doing a histogram of gradients, which is an object recognition part of Python, if you guys are familiar with some of the built-in tools with OpenCV. And specifically what we're looking for is pedestrians. It's not terribly exciting, but it's a good example of an application where you don't actually need every single frame to go up to the cloud. So here we are in that blob URI. Again, we've kind of already classified this. It's gone to our container sitting on Docker Swarm. It's classified it. The container's now put it back onto the results storage account. So now let's go take a look and just kind of see the image that results from this. And we can see the boxes kind of showing the pedestrians being identified, right? So the cool part is now if we go back to Azure, right here, let's see here, we got it right here. We can kind of see that function has already forwarded it back up. So here we are in the positive storage account, and we click on the image here. Go here, actually, I think it's faster. Just go like that. Drop it in. And up in Azure, we have the same image that's come through. Oh, sorry, downloading it. There it is. Okay, so the point being is that, again, we didn't have to send all of our data up to the cloud. We can do some processing at the edge. And so it's really critical to have that capability, but also to have it in a consistent way, right? We're still using that same VSTS tooling, and it's really easy to package up that application and its associated infrastructure and deploy it on the edge. I think that's all for us, so we'll clear the way for some of the other demoers.
Thank you, Matt. Anjay? So this is a pretty common pattern we're seeing in certain industries where they're basically doing this kind of analytics at the edge. It's interesting. We met at an IoT summit. We went out to a lot of IoT thought leaders and businesses that specialize in this. And we'd ask them, well, how much of IoT surface area? By the way, IoT technology is a very broad set of technologies. It's a large suite of capabilities, both Microsoft and open source technologies. We ask them the question, well, how much of IoT, the Azure IoT functionality do you need in Stack? And the answer was, well, all of it. Well, really? All of it? Well, that's like machine learning, that's like Bing Analytics, that's like, there's a lot there. Well, that's going to be a pretty big stack. I mean, there's a lot. Are you sure? That's also going to take a while. Are you going to wait for that? And, well, no, we need it like this year, soon. And so we had to then say, well, what do you really need to do? Help us learn a little bit more about what you're trying to accomplish. And there were some that wanted everything, but by and large, most companies said, well, I'm perfectly comfortable aggregating data and doing my model development in the cloud where I can scale and develop the models. What I really need to do is score and operationalize the models on premise. And that's kind of what Matt and Anjay were just demonstrating, this operationalizing a model on premise where they're scoring and doing the pedestrian recognition. But that could also be working on a factory floor, for managing the factory floor or an oil rig. So those models can basically be developed in Azure and then shipped out into Stack environments for scoring, and then doing interesting processing and forwarding to Azure as necessary. Okay, so that's one class of application that we see companies develop. Okay, another common use case, remember we went back, one was edge and disconnected, another is regulation. This comes up a lot, again, in healthcare and financial sector, and usually this comes up in scenarios where there is some form of regulation that prevents them from putting all their information in Azure Public Cloud. So they need to store some. How many people in this room are from regulated industries? Okay, so this might be relevant. So in this scenario, we're going to have Scott come up and do a demo of this, but we were talking with a healthcare company. And in healthcare, here's an interesting situation. In the healthcare industry, there's something called open enrollment. So during open enrollment, 1 month a year, a lot of demand. Everyone's going to log in, shop for their plans, buy a plan, sign up, and do all that data. The rest of the year, not so much. People might browse, they might not. Traffic is really low the rest of the year. So 11 months of the year, not much traffic. 1 month a year, a lot of traffic. Now, this particular company had a constraint. All of the data needs to stay within the corporate firewall. That data is not going outside. It's part of, we keep all PII information on premise, we keep all that data there. So they needed to make sure the data stayed in their walled garden, but to meet the capacity during open enrollment, what do? Build out a lot of capacity on premise, use it for 1 month, and then what? It sits dormant the 11 months of the year? Or they put other workloads on it and then vacate them when they need it again during open enrollment? How do they manage that? What they were saying is, I would really like to use Azure capacity during that 1 month of the year, and then the rest of the time, just live in Azure Stack. So Scott's going to show you how they did that.
Thank you, Brad. So, by the way, I'll do another show of hands just because I guess you can't come up here and not ask people to raise their hands. When's the last time you went to a session where you had like 6 live demos? Not movies, live demos. So we're basically saying to the demo gods, come at me, bro. So hopefully everything works. I'm going to show. All right, so the scenario that Bradley was describing is something that we call, well, we've got a customer that's got an application that's on site. They've got infrastructure deployed on site, and they've got data that, for regulatory reasons, needs to stay on-prem. In other words, they don't want that in the cloud. And the particular application I'm going to show you is one that we built that it's a healthcare application. For those in the States, if you're familiar with the Affordable Health Care Act, or as some call it, Obamacare, they had basically a period where they released the application. Everybody just hit it all at once, and there were some issues. So it's a very popular model to have that ability to sort of have infrastructure spin up in the cloud automatically to take that to offload that traffic onto. And so that's what we've built here, is something that sort of shows that. And in the diagram here, I'm just showing the basic architecture of the application, which has front-end application servers deployed to Azure Stack. It's got the database tier in the back end that's really instances that are running on-prem in Azure Stack. And then we've got an app piece in Azure that we can spin up. Now, the entire thing is actually, we've got front ends that are connected to the internet, and we've got, of course, Azure on the internet. The database tier is not exposed directly to the internet. It's instead exposed via a site-to-site VPN tunnel. And so we want those, when that traffic peak hits, we want to be able to spin up those instances in Azure, but we don't want to have the data go to Azure. We want those front ends to talk back to the database on-prem. And so that's what we've built. So let's just show, switch this here. Oh yeah, that's perfect. That's exactly what I wanted. Okay, so, wow. All right, that got small. Yeah, come at me, bro. All right, well, so this is the, yeah. So you saw in some of the other demonstrations, we got our Visual Studio app here, the Northwind Insurance application, and we have two deployment sites essentially defined, one for Azure, one for Azure Stack. And when we spin up a new build, we want to just be able to easily deploy that application to one or both sites. So we want to make sure that the application is consistent in both sites. So it's good for dev test scenarios. It's also good for scenarios like this where you want to be able to handle that increased capacity. So I'm going to next go over to our Azure side. And we actually have a traffic manager handling our URL. So we can either we point to the on-prem instance, and if conditions change, we can actually point to the Azure instance, and so that traffic goes to Azure. And that's kind of what we've done here. So we've built we have a couple Azure functions. You could just, they're running in Azure here. You could just as easily run those functions in Azure Stack. It actually doesn't matter. And what those are doing are basically looking at something simple like page requests per second threshold. So once we hit a certain page requests per second threshold, we want to be able to trigger that function. It'll actually burst into Azure. So we're going to spin up those instances in an availability set and a scale set. And have Traffic Manager go ahead and point users to the Azure instance and away from the on-prem so we don't completely tip those things over. So that's what we've got here. And let's just take a look at our traffic. So using my scanning electron microscope, I'll find that lives metric stream. Okay, sure. So here's our live metric stream from App Insights. Hopefully folks are somewhat familiar with App Insights. So we've got our App Insights agents on the application, and we can take a look at the incoming requests. So we have traffic now going to the Azure Stack instance where we want it now because we haven't hit that open enrollment period, right? And we've got some requests coming in because it turns out there's some regular traffic, and even though this app it isn't real, it's really for demoing purposes. It turns out if you put any form on the public internet that even has a social security number field, you will get traffic. So here's our open enrollment form, and I don't know if you can see this. Again, let me just grow that here. All right, is that better? So you can see the little blue banner up here at the top. It says we stuck that in there. This page is loaded from Azure Stack. So now we're hitting Azure Stack. Let's refresh that. Okay, so we're about to start, and actually anybody could go hit this if they wanted to, because it is out there and live. The data doesn't actually go anywhere. Well, it goes into a database. We don't actually have healthcare insurance that we're selling you, so. But you could hit the site. In fact, if you wanted to go ahead and do some open enrollment now, you're more than welcome to. All right, so let's do, I'll tell you what. Let's just, so just in case you guys don't allow us, you're not enough traffic to trigger our threshold, I'm going to go ahead and simulate some load, in addition to you guys all obviously going out and hitting the site and enrolling. And let's go ahead and hit that site. So first, let's take a look and see. Okay, so it looks like we've ticked up in our traffic, and so now by now we should have bursted into Azure. So let's go ahead and open that site. Okay, so it's a subtle difference. But you can see the little green banner indicates very clearly, again, under your scanning electron microscope, that the page is loaded from Azure and not Azure Stack. Can everybody see that? Yeah? Okay. So what the heck? Let's go through and enroll. Where do you live? Okay, well, I actually live there. And sure, why not? Tobacco use, of course not. I am actually male. And, oh, what the heck? All right, now let's take a look at the plans. Oh, well, you saw my income, so clearly I'm going to go for gold. All right, and let me just go ahead and enter my deets here. And sure, that's where I live. Oh no, I'm the next house. All right. Okay, so yeah, that's auto-genned. All right, so let's go ahead and submit that application. Okay, we are enrolled. Now, I'm going to go back to our environment here, which we can see, which fortunately does not require us to VPN back into CorpNet. Our friends at Rackspace were gracious enough to lend us this environment. So thanks, folks from Rackspace. So let's take a look. I'm VPN'd in, and I've got an RDP instance to our database server here on the back end. All right. So let's just go ahead and, oh, thank you, thanks. That's cool, it was readable before. We didn't want that. All right, so surely there's a way to make that larger. F5? F5, you say? That's not going to do anything. Oh, okay. All right, so yeah, you can't really see it. But let's see if I can fix this so that you can. Yeah, that was my failure. I heard it in the audience. I can't believe I didn't hear it before. Zoom it. If Rusinovich was here, oh man, I would really be in trouble. Oh. All right, so all right, let's try this. I'm going to throw it over here. And yeah. Okay. So hopefully you can see down there, or at the top, there I am. There's my enrollment entry. So my data went back to the database on-prem. And we handled enrollment. So that's it for me, I think. With that, I'm going to turn it back to Brad. Thank you.
All right, the use cases you've been seeing are actually modeled off of real customers' use cases that they're using for the hybrid cloud. And you saw some consistent themes here. You saw themes about using VSTS. You saw themes about consistency, about deploying application artifacts that are spanning these cloud boundaries. That's what Azure Stack is enabling. Hang on just a second here. We're going to move forward. So we're just about out of time, but I want to capture a couple of things before we go. Yep. For those of you who don't know, Azure Stack is consistent with Azure, especially with API profiles. There's a consistent subset you can use for targeting both Azure and Azure Stack. We are continuing to deliver more in Azure services into Stack over time. There are services, we haven't even showed you app services today. Well, you saw some functions that were in app services, but there's a lot of capabilities there. More services coming. It's delivered as an integrated system. That means it's an Azure appliance, goes in your data center and runs. It's an open platform. You know, one of the things here's another phenomenon that we've seen with a lot of customers. They have their Windows developers that do all the Windows.NET stuff. And there's the Linux developers. They do all the OpenStack, Linux, and AWS stuff. And the Windows guys are doing all the .NET stuff and the Windows Server and the Azure stuff. There's kind of these two worlds happening. Well, cloud kind of changes that, really. Because cloud fundamentally is guest agnostic. It doesn't matter whether you're running Linux or Windows. You get the same capabilities as far as the core cloud capabilities. And being open from a platform standpoint, supporting Kubernetes as well as .NET, supporting Service Fabric, as well as other automation, Docker, Swarm. These capabilities are all part of the cloud. So what we're also seeing now is these teams being able to use the same infra and the same capabilities, even using some of the same automation, because they can still use JSON templates, apply the same policy. So cloud is unifying what used to be diverse worlds, diverse camps, my way or your way. And now there is some commonality in the cloud. So I hope you'll take that into consideration as we look at our diverse ecosystem that's available, and it's a growing list. Our Azure partners that are building and syndicating solutions or making their technology available in Azure, for both open source and third-party solutions, have the option of syndicating, making those solutions available for syndication to Azure Stack instances worldwide. Just to keep going here, we're going to skip that. There's service partners around the globe that are going to be operating and making Azure Stack available. So as a developer, you'll be able to target these. There are system integrators that are building systems. Hopefully you know this. Azure Stack is from Dell, Lenovo, HPE, Cisco, and Huawei. Those systems coming. It's basically a way to get going up and quickly. It's a turnkey cloud. It's an extension of Azure. So hopefully this isn't new to you, but for those of you, Azure Stack is an extension of Azure. What does that mean? This is the first time it's new for us for delivering software on-premise and bringing our cloud infra. So you don't have to license Azure Stack up front. You don't have to pay for it. It's not like getting a big Windows Server or System Center license. It's a pay-as-you-use license, just like Azure. When you run something on Azure Stack, it just shows up on your Azure bill, but at a steep discount. Because in Azure, we're paying for ping power and ops, and then on-premise, the ping power and ops are coming from the hosted either IT or a service provider. So that's taken out of the cost. It's only the intellectual property that's part of that IP bill. So it's at a steep discount. So even if you're not running it, anything on Stack, there's no charge then. Right? So that charge only comes for what you're running, just like in Azure. So it is an Azure service. And then we have an integrated support system. Those are really the key takeaways. We're out of time. Here's where you are today. There is a ton of Azure Stack sessions. So we tried to give you just a high-level overview of some of the capabilities that are in Stack today, but there is a ton. So if you want to go deep dive into network, you want to go deep dive into operations, how to run a Stack, there's sessions on that. If you want to go deep into some of the cloud applications, if you want to see Cloud Foundry deployed and how to build Cloud Foundry applications, you can do that. So there's a dev track, there's an ops track. I encourage you to find the track that matters to you and to learn more about this. And for those of you that didn't raise your hand when I asked who had deployed Stack, come on, get with it. You can download it. So thank you very much.